So this is an outline of this content, that is database concept, application of DBMS, transaction concept, transaction state, concurrent execution and serializability. So these are all the content we are going to discuss it now. So first of all, what is DBMS? DBMS is nothing but a software solution to efficiently manage, organize and then retrieve data in a structured manner. That is, it is a collection of interrelated data. Interrelated data in the sense, for example, in university the student database is collected, faculty database is collected. So it is an interrelated data. The interrelated data in the sense, it consists of numericals, alphabets and all the special characters if needed. So that is an interrelated data, and it is either in a manual form or a computerized or online form. So we know the collection of database can be in manual or computerized or in a online form. It is a set of programs to access those data. So DBMS consists of set of programs to access those data. That programming is said to be structured query language. DBMS provides an environment that is both convenient and efficient to use. So before DBMS, it is not easy to convey the information or store the information in an efficient way. But after this DBMS has arisen, it is easy for the customer or user to store the data efficiently. So this is a pictorial representation of DBMS. This is user and this is application. For example, we can take our mobile phone. So we had n number of application and we are the user, and it is connected to DBMS with the help of application programming interface, which is a bridge between the application to the database. So here you can see the application programming interface is connected with the DBMS, and this DBMS in the sense it is connected to the database. So here DBMS means storing of data and retrieval of data. So that is stored in some kind of storage devices, so that only we can able to retrieve it easily. Key features: first is data modeling, next is data storage and retrieval, next is concurrency control, next is integrity and security, next is backup and recovery. So first, data modeling in the sense we need to create the data and we need to modify the data. So if it is not available, then we may not able to create the values and we cannot able to modify the values. For example, in our banking database itself, we can take simply ATM transactions. So previously the ATM transaction is, if we insert the card will be taken by the machine and the card will be inserted into the machine, and after that we may able to see the screen, and we may, after performing the actions whatever we needed, the card will be rippled back. But if there is any error in that, if a power failure or any hardware failure occurs, the card will be stuck inside the machine. So these are all some of the drawbacks when the database have arrived. So with this storage and retrieval, the data can be stored and retrieved easily. Concurrency control in the sense, if we use multiple transactions, then the multiple transactions should give the exact value. For example, in bank they will be using loan database with our current data, that is current account data. If the loan amount has not been deducted or credited into our account, but it has been shown in such a way that it has been already credited, then it means that in concurrent transaction there is some error, so that the bank side has to rectify that error. Data integrity and security. So integrity in the sense, the data should be in the form of original value, and security in the sense the data should be secured. No one should view the data, only the user and the people who is given authorized should view the data. Backup and recovery. Without this backup and recovery, the system cannot able to work, since if backup is not done in a periodic manner, then it is not possible to retrieve the data if any physical calamities occurs, like our server will be down, our Indian bank server, if we are using net banking, it will be down sometimes, and if the backup is not available, we may not able to retrieve the data. So applications of database in banking, entirely it consists of the database. For example, we are using GPay, PhonePe, and we are going for the bank for the internet banking, and we are going for the NEFT transaction. So everything comes under the database. Airlines, so in airlines, reservations, in all the reservations are coming under database. In airlines specifically, reservations and schedules. So schedules, if we go for airport, it will be displaying automatically which are all the flights in flying, which are all the flights are going to land, which are all the flights are going to take off. So it will be displayed automatically, no one is changing that. It will be indicating the flight number and then flight details, which company flight is going to fly, and at what time it is going to land and what time it is going to take off. So everything is made automatic with the help of DBMS. Universities, so in universities the registrations and grades what the students are getting is coming under the concept of DBMS, that is database. Sales, so in each and every company, wherever we go, wherever the shop we go, the entire thing comes under database, since the product in and product out will be taken care by the shop owner with the help of DBMS. And then manufacturing. So in manufacturing, in the industry like TNPL, they will be giving what are all the, they will be knowing what is the production, what is the inventory, and what are all the orders they got, and what is their supply chain. And human resource, so this plays a major role in all the companies, such that employees salaries, employees deduction, employees tax deductions, everything will be monitored and it will be given automatically. Uses of database to avoid data redundancy and inconsistency. Redundancy in the sense repeatedly the data will be shown, and inconsistency in the sense it should show gradually, that is the data should be available in the database without any interruption or without any error, that is data redundancy and inconsistency. So this will be avoided in DBMS to avoid difficulty in accessing the data. So whenever we are storing files in Excel, we are in a trouble to retrieve the data in such way that if we don't know the file name, then we may not able to retrieve the data. But in database, the content, the data is stored in the form of structured manner, so that the retrieval process will be very easy. To deal with data isolation, that is if multiple files are using at a time, that is in a bank multiple transaction will be done, you can see so many counters will be there and so many customers can give the voucher and they can take the amount or withdraw the amount or credit the amount. So if multiple transaction takes place at a time, then it should not give the wrong data, it should give the right data. To deal with integrity problems in the sense everything is programmed manually. If there is any deviation in that, for example, everything can be done only if the account balance is greater than 0. If it is less than 0, then nothing can be done. So that is taken as a constraints. That constraints can be changed frequently also. Next, the uses of DBMS follows as atomicity of updates. Atomicity is nothing but do or die concept. The entire transaction should end with either successful or it should revert back to the original state, that is atomicity. That is, if transfer of funds from one account to another should either complete or not happen at all. This we will be facing in our real life itself. In GPay we will be transferring the amount. If there is any interruption, then the amount should be rolled back to our account. We may notice that if it is not rolled back, we will be getting the message such that transaction not complete or transaction failure, and if the transaction is failed, the amount what we have quoted should return back to our account. If it is not returning back, it means that atomicity property is not given properly in that database. Then concurrent access by multiple users, that is one person can send an amount to another person, the same person account, for that same person account itself another person can send an amount at the same time. So if concurrent transactions occurs, then the database should give the exact result. So multiple transactions should produce the exact result. And security problems. So security problems in the sense, if my phone has been hacked by some users, they should not do the transaction without my knowledge. That's what the T-pin and M-pin has been enabled in all the bank transactions what we are using in our mobile phones. Next is transaction concept. So transaction is a common word which indicates that if we are doing any fund transfer or fund credit or debit or loan, anything that comes under this transaction. It is a unit of program execution that access and possibly updates various data items. The data items can be of credit or debit or loan, or it may be of some other things what the bank is providing the service. It may be of NEFT or IMPS, any kind of service which is provided by the bank is said to be a transaction. So here you can see a program which means the from account A 50 rupees has been credited to account B. So here we can see first the data A is read, and from data A 50 rupees has been reduced, and after reducing 50 rupees the amount has to be written. That is, if it is 100, A value is 100, then the value has to be written here as 50. And next read B. So the original value of B should be read, and in that B value 50 rupees has to be added. If it is again 200 rupees, after adding this 50 rupees it should be of 250 rupees. Then that value has to be written. So this is a small introduction about a transaction. Transaction concept. So it deals with mainly it deals with two issues, that is, if a system or hardware failure occurs or system crash occurs, then the transaction should go back to the starting state. So that is said to be a rollback. So this when I am discussing with my colleague, he asked one question, if I am doing a GPay, if suddenly the internet has been cut down in my mobile, either my amount has been cut, how would I get the amount what it has been transacted? So that are all some of the issues which has been faced in the transactions, which is in a process for rectification. So it should go to the starting state, or it should end with the successful state. That is, the amount has to be credited to the person who have been added, or it has to return back to our account. That is the first issue. Concurrent execution of multiple transactions. This is what I said. If 100 transaction takes place, for example in Indian Bank itself, we may see so many times the server is busy. We can able to see the message as server is busy. It means that there are multiple transactions, that is thousands and thousands of transactions are taking place, so that the server may not able to give the original data. That's what it means. So again the same fund transfer example is shown, because for atomicity in step 3, if the problem has occurred after step 3 and before step 6, what happens? That is, the amount has been reduced with first account A, but before reading or adding the amount to B account, the system has crashed. Then what happens? The amount will be reduced in A, but it will not be debited in B. So what the system should do? Previously it shows that at least wait for 3 working days for sorting out the issues, but nowadays it is not saying like that. It will be saying in such way that rectified within half an hour, or it will be rectified immediately. So the amount will be rolled back. In reservation we can see this, or in a GPay we can see this, in phone pay we can see this, or in a ATM transaction we can see this. Once our card will be inserted, the amount what we had entered will be taken, and if the power supply has gone, then the amount will be reduced in our account and the message will be shown that the amount is reduced. But after power failure occurs, the amount will not be able to come back to us. So in that, atomicity property plays a major role. So nowadays the rollback concept is implemented, and that power failure, for that system crash also, the backup has been done immediately. 0-second power failure will be available. Like within a 0-second, the power failure will be rectified with the help of generator. Next is durability, that is when the system is used wherever we are in need of. That is, if I am using the ATM in Namakkal, and if I am using the ATM, same ATM in Karur or in some other Tirunelveli, then the amount should show the same thing what it has. It should not show in a flaws. Like if my account consists of 10,000 rupees which is available in Namakkal, if I have not done any transaction, the same 10,000 should be available when I am seeing the balance in Karur or Tirunelveli, wherever I go. So that is a durability. Consistency. So consistency in the sense, if the values will not be unchanged after the transaction, then it is said to be a consistency. Example of fund transfer. So the sum of A and B is unchanged by the execution of the transaction. That is, first in account A the amount will be reduced, and in account B the amount will be added. So there are some integrity constraints, that is, if the amount is not available in account A, then what happens? The amount cannot be reduced. So there are some constraints available in such a way that our minimum balance in the bank should be 500. Without the minimum balance in urban bank 500 rupees, we may not able to withdraw the cash. Once we will be giving the credit, that is debit voucher, they will be checking our balance in such a way that whether our account consists of above 500 rupees or below 500 rupees. If it is below 500, we may not able to withdraw the cash. So that is a major integrity constraint. And if you are going to close the account, if there is any loan in our bank, we may not able to close our account. In the sense, we had loan, we need to rectify, close that loan, and then only we may able to go for the closing of account. So that are some of the integrity constraints. So these are all the things what we had already discussed. This is again the second example. Here the transaction 1, the data, the account A has been reduced with 50, and in transaction 2 the write operation takes place. So here in transaction 2 it will not write the exact value of A, since here in read A the value of A has been reduced, but in transaction 2 the value which is available in A will be written. And after this, if it is performing the addition of 50 rupees in the second account, it means that the values will be not exactly available. So this shows the isolation property. So transaction is a unit of program execution that acts as possibly updates in various data items. So in transaction the main properties are asset properties: atomicity, consistency, isolation and durability. Atomicity is either the transaction should take place or it has to return back to the original state, that is do or die operation. Consistency is it should be the same before and after the transaction, that is when the operation has been performed the value should remain changed before the transaction and after the transaction takes place. Isolation in the sense it is the multiple transaction occurred without any interferences. So interference in the sense if any error occurs, then the system should go to the original state or it should complete the transaction. Durability, the changes of successful transaction occurs at the end, that is durability. So this is implementation of atomicity and durability. So this is a shadow database concept. Previously we will be having only one point, that is only one copy of database, but nowadays in order to have a recovery, the another shadow copy will be created in order to establish the atomicity and durability. Here for this a best example is our Indian Bank server will be available in the head office, and in that server it will be interconnected with multiple servers. If it is not interconnected with multiple servers, the users may not able to retrieve or do the transactions in a successful way. So that are all the additional servers which are all connected to the server which is available in the head office are said to be the shadow copies, that is backup copies. So next is the transaction state. So with this diagram it is easy to see what are all the transaction state. First is active, that is when the transaction is yet to start, then the state is said to be in a active state. Then it goes for either partially committed or failed state. So partially committed in the sense the transaction should be in the completion stage. So the transaction is going to complete, that is partially committed, and after this state it goes to committed. Committed in the sense the transaction has been completed and it is going to give the original data, that is the committed state. In other terms, if the transaction is going to start but because of some problem it is not able to execute, then the transaction will enter into the failed state. So this we will be experiencing in an ATM. So wherever we go for an ATM transaction, first we will be inserting the code, that is the active state. So it will be reading our name and it will be providing the account number of our details, last 4 digits. So that is the system enters into the active state, it is going to start. And if you are entering the amount and the amount will be taken by the ATM machine and it is going to give the amount, means it enters into the partially committed state. And after giving the amount, the machine will be giving the available balance. So that available balance is said to be the committed state. So this is one type of transaction. And another type of transaction, when it shows our account details and our name in the screen, after that some power failure occurs, so it may not able to proceed. What it does, it will be going to the failed state. So the ATM card will be taken back, so it will release the lock and we may able to taken back our ATM card. So once the power comes only we may able to take the ATM card. So that is said to be failed state. So the operation, the transaction is aborted. So we may hear this word aborted in many of the films, that the action will be terminated at the place where the process is going to end. So if I am standing here, if I have been said abort, then I have to stop my speak and I have to stand simply. So that is an abort operation. And here one more operation is, if the transaction has been in a processing state and after the processing state, if any transaction failure occurs, that is when the amount is yet to come, and if any process that is failure occurs, power failure occurs, means then it should come to the failed state, since the amount has been reduced from the account but it is not been given to us in hand from the machine. So it is of failed state. What the system should do means, it has to again roll back to the starting state in such way that what amount has been reduced from our account will be rolled back and gives the starting state amount which has been available in the account. So that is the abort state. Next is schedules. So schedules is nothing but where we will be prioritizing the work, that is said to be schedules. That is, if I am having 10 works in a day, then I need to schedule my works in such a way that whether if I have 10 works at a time, then I need to prioritize the work in such a way which has to be given the first priority and which has to be given the second priority, and in what schedule I have to complete the work. That is, in morning I have to complete this entire schedule and in evening I have to complete this entire schedule. The same thing is followed in the transaction also. So we can see an example. So here we can see in transaction 1 and in transaction 2, here the first transaction, account A has been reduced to 50 and it has been written, and the second account has been read and it has been added with 50 and and the value has to be written back, and at last commit will be given. Commit in the sense the program is going to end, that is, after commit no transaction will take place in this transaction, that is said to be commit. In second transaction, so this is a concurrent transaction, that is, when this read A starts, this second line, when it started and goes to the second line, this read A will be started in the transaction T2. So what it happens means, it should schedule in such a way that whether this transaction has to be taken place first or this transaction has to be taken place first. So here you can see 10% of amount in A should be taken back and it has to be credited in B. So for that a temporary variable is created, and for 10% it is indicated as 0.1, and it has to be multiplied with the available balance, and it has to be reduced from that account, and it has to be written, and after that it has to be added with the account B, and it has to be written back again, it has to be committed in the sense it has to be end the transaction. So in general I am going to conclude this. With the help of DBMS we may able to read the data and retrieve the data and manage the data using queries, and we may able to indicate the data in the form of structured manner. And there are a lot of concepts available in DBMS. We had seen only a small concept called transaction, where we are doing our day-to-day activities in a bank using this transaction. Thank you.